Let's get started. We're going to talk first about the first part of Chapter 1, Sections 1.1 through 1.5.1. And actually, we'll skip like the first few parts that are just general. Most of that was in the course introduction. So let's start off with 1.4 in the text, which is about problem-solving strategies. And our idea here is to talk about this state of mind that we're trying to get in programming, the way that we attack problems, break them down, and solve them. Okay, that's really what our computer science and our programming classes are about. So let's look at a strategy for doing that. At Doan, you're going to hear a lot about the Radius problem-solving framework, which starts out with this recognize step. In the recognize step, what you're trying to do is figure out what problem it is that you're trying to solve. You can't solve the problem if you don't know what the problem is. So that's the first part of the process, is understanding that. The next step is to analyze, and that would be where you'd think about various options for solving the problem. So if this is a brand new thing that we're going to do with a computer, maybe one of the options is don't do it with a computer. Maybe, the way that we used to do it is the best way, or maybe I can use this technology to do it, or I can use this other technology to do it. So we would consider different options that we have for solving that problem. Then we'd have our design step. And now we're going to think about, when we settled on the tools, so to speak, or the different options that we're going to use, now we're going to solve it. We're going to figure out the steps that we're going to use to solve the problem at an abstract or high level. Then our next phase will be implement. In the implement phase, we write our solution in some programming language. And this class will be using Python. And then the last step in Radius would be support. And that would be where you would fix or improve the program that you wrote over time. Okay? Now we think of these as being linear, flowing from one to the other. In reality, they'd be more circular, where you'd sort of go back and forth between analyzing and designing and implementing and so on. So let's map this onto the strategies that the book presents, because they map very nicely to this Doan framework that you're going to see all the time. They call the analyze phase a strategy phase, where you find some high-level idea for finding a solution. And we'll take a look at a couple of strategies here in a little bit when we talk about a handshake example. Our design phase, they call tactics. Those are the methods or patterns that you use that work in many different settings. Okay, so we might have later on an accumulator pattern, for instance, that we'll look at. And then finally you have your tools, and those are the tricks or techniques that you use in specific situations, including the programming language that you're going to write your program in. Okay? So this is overall our problem-solving framework. Again, at Doan, you'll hear a lot about Radius, recognize, analyze, design, implement, support. In the book, they talk about the analyze, design, and implement phase as strategy, tactics, and tools. All right, we're going to take a look at a handshake example that they have in the text to show some of the general strategies and tactics that we might use when we're solving problems. And this sort of gives you an idea of how we'll think about things when we move on to doing some actual programming. So here's the question that we're trying to solve. We've got 12 students in the class, and at the beginning of the class, then every one of those students has to shake hands with everybody else. We'll say this is pre-COVID-19, so we were still shaking hands. And the question is, how many handshakes take place? Well, what we might think is that there are 11 other people besides myself if I'm in the class, so I've got to shake with 11 other people. Everybody has to do that, so we'd have 12 times 11, which is 132. And that's our answer, right? Well, no, it's not actually. And so let's take a look at how we might do this. We're going to apply a couple different ideas here. So we're going to do a simplification strategy first. And that is, we're going to reduce the problem to a trivial size and then see if we can find a solution based on that, sort of build up in our thinking. And then we'll do generalization to go from a specific example to a general solution that would work in all the cases. So here's our simplification and generalization in practice. If there's only one student in the room, how many handshakes are there? Well, there's none. I mean, unless you're doing this, right? The person is shaking hands with themselves. So there's 0. If someone else comes into the room, a second person, how many handshakes are there? Well, there'd be 1 between the 2 people that are now in the room. Okay? Now, suppose a third person comes in. How many new handshakes are there? Well, the third person has to shake hands with 2 people. So there's 2 new ones. And therefore, our total is 2 plus 1 plus 0, or 3. And this pattern continues. If a fourth person comes in, there are 3 new handshakes. So now our total is 3 plus 2 plus 1 plus 0, or 6. That's the number of handshakes that take place. Whereas our previous reasoning would have said 4 times 3, or 12 total handshakes. Okay? So that's our simplification. We're starting to see a pattern here. Now we can generalize. If we generalize this, then we would say for n students, there are 1 plus 2 plus 3 plus ... all the way up to n minus 1 handshakes. So if there were 4 students, then n minus 1 is 3, plus 2 plus 1 plus 0 is 6. Okay? And we can go a bit further. We could solve this with a formula that says if I want to find the sum of the first n integers, that's equal to n times n plus 1 divided by 2. And if you take a look at the text, if you've read that, I hope, you'll find the really neat geometric argument for that. But if you don't want to do the geometric piece, you can just sort of take our word for it. So this would tell us if n is 12, there are 12 students, then I have to go from 1 to 11 in terms of the number of handshakes. So I would have 11 times 12 divided by 2. So that would be 132 divided by 2, which would be 66. So there's 66 total handshakes rather than 132. Our previous thinking was overcounting by a factor of 2. All right. In our next video, then, we'll start talking about our programming language, in particular, Python.